focus then quickly on the milestones of the development of that special machine type. Then also on the variable density TBM, which is the new kind of soft ground machine technology, also for the application in quite high variable ground conditions, quite permeable conditions, but also for conditions with karstic features, and to conclude then with an outlook. So the motivation for the development of multi-mode machines goes back to our history. We developed these machines for the first time mid of the 1980s. In the past, there had been several projects that had been characterized by geological conditions of long stretches in soft ground beneath the groundwater level, in parallel with long stretches here in hard rock and soft ground. So for these situations, we looked for a safe solution to do these works, but not only to look on the safety side, but also to look on the financial side, to have an optimized solution at hand to safely and reliably realize such tunneling projects. So that's the background of how we developed the multi-mode machines. The multi-mode machines go back on three basic machine designs. The shielded hard rock machine, so you can operate the machines in an open mode. You can also operate the machine in a closed slurry mode. That means with a slurry supported tunnel phase or with an earth pressure balance shield. So a combination of all the basic machine types is possible. A change in the tunnel is possible. They can be designed to do a modular conversion. That means if you have a small amount of section either in hard rock or soft ground, you can start to operate the machine in hard rock, and then for the modular, if you want to change in a slurry mode, for example, you do an exchange of components. Also to bring in pumps and a stone crusher that is required. You need then a shaft or a cavern to do that change. Or you can have that machine with an integrated solution to convert between the modes that can be done within hours. And sometimes, dependent on the logistics, this can also take shifts or days. But it's more or less you can just push a button and change from an open mode to a closed mode or between the closed mode principles. So the first example of these machines I want to show is a change that can be done between an open single shielded machine to a closed earth pressure balanced shield. In unstable conditions below the groundwater table, the machine can be operated as a closed earth pressure balanced mode. That means you have here the chamber completely filled with material to act against the earth and water pressure at the tunnel phase. The muck is taken then through the screw conveyor. The pressure here is reduced via the screw and is handed over under atmospheric conditions on a conveyor belt. If you have now stable conditions, but you have amount of water, and then you can operate that machine type in a compressed air mode. That means you drive the machine with half the chamber filled with material, and the upper half of the chamber you put compressed air. This is to keep the water away, and you can take the muck out, and also it's a dry mucking out. In stable conditions, with just a little bit of dripping water, that machine can be operated entirely in an open mode operation. Then you feed the screw just with enough muck to be transferred out of the excavation chamber. So that machine, with that machine type, the muck is always taken out of the excavation chamber via the screw conveyor. And here the difference between the two modes is that in a closed EPB mode, the screw is additionally used to reduce the pressure. Such a machine was used for a rail tunnel, two parallel rail tunnels of 9 kilometers each at the southwest part of Germany. The geological condition comprised mainly marl, sandstone, and limestone formations. There had been 2 low-cover zones with unstable conditions in the portal areas and 1 fault zone in the center. So for this situation, the machine was driven in a closed earth pressure balanced mode, and for the remaining section, the machine was driven in an open earth pressure balanced mode with muck extraction through the screw conveyor. You see here that's the portal area with the 2 parallel machine drives that had to underpass here than the mountain. The machines here, like I mentioned, operated mainly in an open mode. The screw conveyor was always the primary mucking system, and the screw conveyor could be used also in open mode due to moderate soil abrasiveness. That's quite important also to have a focus on the wear that is prevailing. It looked different for a project, was exactly the same conversion between an open mode to closed mode and vice versa. For a project that was done in France. It's also for a rail tunnel job, 2 parallel sections of about 4 kilometers that had been excavated using 1 10-meter diameter multimode machine. It was operated along the Meyer section in an open mode. That means here the muck was extracted here or taken out of the chamber via the screw conveyor and further on with the belt conveyor. And for the softer formations in the portal area and the fault zone, it was operated in a closed earth pressure balanced mode. In a closed mode, the muck was extracted through the screw, and in the open mode operation, it operated as a single shielded hard rock machine with a muck ring in the center, and the muck was taken here to the center on a belt conveyor out of the tunnel. That's the machine at the portal area to convert from an open mode to a closed mode. It took about 4 days to do the conversion. The time that was used was mainly based on adaptations to the cutting wheel. To change to closed mode operation, you have to have to also disassemble here the muck channels that you normally have in an open mode operation, and then also to adapt the logistical systems. The most frequent conversions with multi-mode machines is between open single shielded machines to closed slurry mode. This is more or less based on the complex geological conditions for Meyer projects around the world, more frequent application. You see on the left-hand side that machine type that operates in a closed slurry mode. You have here the bulkhead that separates the pressurized area from the pressurized area. You have here the 2 chambers with the air bubble. With that, you precisely can regulate the pressure. The muck is taken out, and here, if you have boulders or big stones, they can be crushed down here with an installed stone crusher to a transportable size, thus that you can hydraulically convey the muck. The muck consists of a bentonite soil mixture. It's transferred to the surface in a separation plant. The muck is separated from the slurry, and the slurry goes back here in the slurry circuit. In an open mode operation, you have here the center belt conveyor move to the front. You can completely seal off the second chamber, and you can operate the machine in a hard rock mode with mucking out through a muck ring and center belt conveyor. Here, that conversion between the different modes can be done within 2 to 4 hours. It depends, of course, on the logistics on site. It can also sometimes take 2 to 3 days or a few shifts, dependent on the specific project conditions. That machine type was for the first time used end of the 80s. And there had been several other projects, also like a project that was realized a few years ago in Switzerland, in Zurich. In Zurich, you have here the main station. It was a dead-end station in the past. They did a new design to have a drive-through station and to connect the rail line with the airport. That tunnel had an overall length of 4.8 kilometers. Operation started here from the tunnel portal towards the station area. The mayor section here had to be excavated in molasse rock, that's sandstone, marlstone formation, rock formation of medium rock strengths. And only for the last 250 meters of in total 4.8 kilometers, the machine was converted into a slurry machine. This mainly before underpassing here the river. And here they had more gravelly soil-like material when the machine had to drive towards the main station. Another change between an open mode type to a closed slurry machine type was used for a quite challenging project in the United States. It was realized close to Las Vegas. It's called Lake Mead Intake number 3. So close to Las Vegas, you have the Lake Mead, and the water from that lake is used to supply Las Vegas with fresh water. There had been 2 existing intake structures, but due to the drought situation in that area, the water level in that lake drops. And if it's further dropping down, then the 2 intakes, the existing ones, run dry. And so they looked for a new concept to design a much deeper tunnel to guarantee the future delivery with water to Las Vegas. So a 180-meter deep shaft was built. It had a diameter of 9 meters. There was a cavern. From that cavern, in that cavern, a machine was installed to excavate a 4.8 kilometer long tunnel. And the tunnel drove into an intake structure that was lower down in the lake before. The specific project conditions had been quite demanding due to sedimentary and volcanic rock formation, and also with quite a number of fault zones that were predicted along the alignment. And because of the fault zones, there was the risk to have a communication with the lake, and so therefore the machine had to be designed for up to 17 bar. The machine configuration looked like that it could be operated in a complete closed slurry mode, like you see on the left-hand side, with the double chamber system with the air cushion and hydraulic conveying of the material. This machine could be converted relatively quickly to an open mode drive, where the muck was taken not on a conveyor belt but on a long screw conveyor, and further processing on a belt conveyor. Here it was written in the machine specifications that to convert from an open to a closed mode should be realized within 120 seconds. And that's why we designed the machine here with a long screw conveyor. You could quickly reverse the screw, completely seal off the front area to be able to take if you have a sudden water inflow, to cope with that situation. It was equipped also with extensive grouting, pre-grouting installation screw conveyor. You could quickly reverse the screw, completely seal off the front area to be able to take if you have a sudden water inflow, to cope with that situation. It was equipped also with extensive grouting, pre-grouting installations that you could do a pipe injection umbrella from within the machine for the worst case scenario. That machine operated between December 2011 to December 2014 for the 4.8 kilometer long tunnel under pressures well above 14 bar. And you see that's the breakthrough of the machine in that intake structure. Another conversion, the change between slurry shield and earth pressure balanced shield, can also be done. On the left-hand side, you see typical earth pressure balanced shield. On the right-hand side, a slurry machine. The difference of the two machine types is the face support. With an EPB, you have it with the excavated material itself that is used to support the tunnel face. And with a mix shield, you have a slurry suspension that you bring in to support the tunnel face. And that slurry is not only used to support the tunnel face, but is also used as a transport medium of the excavated material. It's also difference of the two machine types in muck extraction, with an earth pressure balance shield through a screw conveyor, and with a mix shield with a hydraulic conveying of the material. For changes between slurry and EPB mode, in the past we had a modular concept for doing the change. If we talk about small to medium-sized machines, that's more in the diameter range of 4 to 6 meters in diameter. The machine had been designed in the past here to exchange the modules or the components that supported the open or closed mode operation here with the slurry machine, or with also in closed EPB mode with the screw conveyor. That was quite time consuming, but for smaller sized machines it's difficult to have a parallel installation. There was a project realized in France, in Paris, for a ring road around Paris, and it was a 10-kilometer long tunnel with a quite high variable geology along the tunnel alignment. There had been sections in limestone that could be operated in an open mode, sections here in more clayey, silty formations where the machine was transferred to closed EPB mode, and sections in sand formation which support typically the operation mode here in slurry mode. Because the machine was of large diameter of 10 meters, it was possible to have parallel installation of the screw conveyor, but also here of the stone crusher and also the slurry pipes that you need to do the change of operation mode. But to do the change, in the past it was essential, or it was a need that people enter the chamber to do some adaptations that support the closed mode operation drives. Here you see the long history of the development of multi-mode machines. We started mid of the 80s, where the first machine was applied for a project in Switzerland that could be converted from a closed slurry mode to an open hard rock mode, then change between open mode operation as a shielded hard rock machine to closed earth pressure balanced shield. And so these are only some key projects. There had been several projects done up to now with this multi-mode operation. So that was the past here, where you have long stretches of conditions in soft soil beneath the groundwater table and hard rock. Today the projects are even more complex, where you have frequented changes between hard rock and soft ground beneath the groundwater table, and also locally karstic features that have to be handled in a safe and reliable operation mode. So based on these conditions, we developed a new kind of machine. We call them variable density machine. This machine type incorporates the advantages of both the earth pressure balanced shield and the advantages of a mixed shield operation. And here the conversion between the mode can be also done for small to medium-sized machines, just by pressing a button, and without, that's important, without the need to enter the chamber to do the modifications, and also under full control of the phase pressure while you do the transition between closed EPB to closed slurry mode. That machine can operate in different modes. In a complete open mode, if you have stable conditions with muck extraction on the screw conveyor and dry mucking out. It can operate in a compressed air mode with half the chamber filled with material, and compressed air mode in a complete full closed mode operation if you have unstable conditions beneath the groundwater table, but also in a slurry mode with an air cushion with the 2-chamber system, or that's why we call it variable density mode, with a higher density than the normal slurry density. We talk here about densities up to 1.7, 1.8 tons per cubic meter. So it's a thick, it's like baroid material that you have. And then you can also, in highly permeable soil, that you are able to keep the phase pressure and avoid settlements or sinkholes on surface. Such machines had been applied for the first time to a metro project in Kuala Lumpur. They had been used for a 9.8 kilometer long section. And we have currently a machine operating in Hong Kong. And there was one design for a project in Peru for the Metro Lima. But the project is at the moment a bit delayed. So the machine will be earliest in use in mid-end of 2018. So to conclude, their projects of today, they're more and more complex, more and more variable geological conditions have to be faced, locally also with some high hydrostatic pressures, and with so-called custom-made or tailor-made solutions. We look for more safety and also to look on the economical impact of operating a machine. And to adapt it as good as possible to the prevailing and predicted geological conditions. With that, I'm at the end of the presentation, and I'm free to take some questions. Thank you for your attention.